In section 3.5, I'm going to go over how to solve linear inequalities, both algebraically and graphically, and how to apply this to real-life situations to make predictions. Now, an inequality is similar to an equation, but instead of having an equal sign in it, since it's an inequality, it's either going to have a less than sign, or a less than or equal to, or a greater than or equal to sign in it. First, I'd like to go over how to solve algebraically. Now, we solve an inequality in very much the same way we solve an equation. We're allowed to do the same thing to both sides of an equality, the same as we are with an equation. For example, we can add or subtract the same quantity from both sides of an inequality. We can also multiply or divide both sides of an inequality by the same quantity. But here's where we have to be careful. Whenever we multiply or divide both sides by a negative number, we have to reverse the inequality symbol. Now, it's extremely important we remember to do that whenever we multiply or divide by a negative number, because if we don't, then our solution set won't come out to be correct. Okay, so let's look at an example to see how this works. Here we have an inequality given to us, and notice we have a less than sign in the middle. That's what makes it an inequality. And one thing to remember is that we're trying to find the solutions to this, meaning we're trying to find the values of x that would make it true. And with an inequality, there's more than one answer. There's actually a whole bunch of different numbers for x that would make it true. So we're trying to find what's called a solution set. It's not just going to be one solution or one number. It's going to be a set of numbers that make it true. Now, the first step would be to distribute to remove the parentheses. So let's do that. So we get 3x plus 12 plus 1 is less than 5x minus 10. And then we'll combine our like terms together. So the 12 plus the 1 would give us 13. So 3x plus 13 is less than 5x minus 10. Notice I'm treating this very much like I would if it was an equation with an equal sign so far. Now we want to get the variables on one side and the numbers on the other side. Now, in this kind of a problem, when it's an inequality, I think it would be best to always try to get the variables on the left side. So we're going to subtract 5x from both sides. That would give us negative 2x plus 13 is less than negative 10. And then we're going to subtract 13 from both sides to get the numbers on the right side. So we have negative 2x is less than negative 23. Now at this point we have to divide both sides of the equation by negative 2. And here's the key step here. Since we're dividing by a negative number, we must switch this inequality symbol. Right now it's a less than. We're going to turn it into a greater than sign in the next step. So we would have x is greater than, and then we have a negative divided by a negative, so it would just be 23 over 2. Or I could write it as a decimal as x is greater than 11.5. You can leave it as a fraction if you want to, or a decimal. Now there's actually 4 different ways of expressing an answer to an inequality. The way that we've got it right now, right here, is called an inequality. So I'll write that next to that answer. That's an inequality. And that's one acceptable way of writing the answer. But there's a few others. We can graph the solution set on a number line. Okay, so let me show you how that would look. We'll just make a number line and we'll plot the 11.5 on there. And we want to represent all numbers greater than 11.5, so we want to shade to the right of 11.5. And since in this case we don't want to include the 11.5 because it doesn't say greater than or equal to, we'll put an open circle and then shade to the right of that, like this. And we'll put an arrow to show that it goes forever. Now if you did want to include the endpoint, if you had a greater than or equal to sign, then you'd fill in that dot at 11.5. So that's a graph. Another way that we can write our answer is called an interval. So using an interval notation. And for an interval, you always put the lowest number on the left and the biggest number on the right with a comma between them. And you enclose the whole thing in either parentheses or square brackets, depending on whether or not the endpoint is included. If the endpoint's not included, you use parentheses. And if the endpoint is included, you use a square bracket symbol. Now if we look at the left endpoint as 11.5, and that's not included, so we'd use a parenthesis, and then we'd put the 11.5 down, and then a comma, and then we want to see what the biggest possible answer is. Now this goes forever to the right, so it goes to infinity. So put an infinity symbol for the right hand limit, and you always use a parenthesis next to an infinity symbol, because infinity is not exactly a number that you can include even. So that would be the interval form of the answer. And then we can also describe the answer in words, so verbally. And that would just be saying by all numbers greater than 11.5. So all numbers greater than 11.5. So all of these different ways are acceptable ways of writing an answer, and if the problem asks you specifically to write it a certain way, then you should follow the directions and do that. But if not, then any one of these ways would be a good way to write your answer. Now one last thing to point out here is to kind of check your answer. If any number that's greater than 11.5 should make this original statement come out to be true when you plug it in for x. And any number that's less than 11.5 should make it come out to be false. So one way to check is take a number that's just a little bit bigger than 11.5, like 12. And if you plug that in, 12 plus 4 would be 16, and 3 times 16 is 48, plus 1 is 49 on the left side of the equation. And then when you plug 12 in on the left side, 12 minus 2 is 10, and then 5 times 10 is 50. So you end up with 49 is less than 50. And that's a true statement. And so that checks that 12 actually is a solution, and that's one of the numbers that's shaded here. And if you pick a number that on the part that's not shaded, like 11, and plug it in, you'll see that it comes out to be false. And if you work that out, 11 plus 4 is 15, 3 times 15 is 45, plus 1 is 46 on this side, and you only get 45 on this side. So the statement says 46 is less than 45, and that's obviously false, proving that that's not a solution. Now let's try an example that has fractions in it. Now remember, when we had equations with fractions, our strategy was to get a common denominator in all the terms. And we're still going to use that here. So in this case, if we look at these three denominators, 3, 6, and 4, the common denominator would be 12. So I would like to rewrite these so that they all had 12s in them. So in the first case, 3 goes into 12 4 times, so 5 times 4 would be 20, so it would be negative 20 over 12. And then 6 goes into 12 twice, so 1 times 2 is 2. And then on the other side, 4 goes into 12 3 times, 7 times 3 is 21. Okay, I forgot my W right here, so let me go back and put that in. Now we'll multiply both sides of the equation by 12. Now 12 is a positive number, so we don't have to worry about reversing the inequality symbol this time. And when we multiply both sides by 12, that's going to basically eliminate all the denominators and just give us negative 20w plus 2 is less than or equal to 21w. And remember, we want to get our variables on the left because it makes it easier to interpret the final solution when the variable is on the left-hand side of an inequality. So I'm going to subtract 21w from both sides of the equation. and that gives me negative 41w plus 2 is less than or equal to 0 because there's nothing left on the right side. And then I'll subtract 2 from both sides of the equation, which gives me negative 41w is less than or equal to negative 2. Now I have to divide both sides of the inequality by negative 41. Now I'm dividing by a negative number, so that is going to require switching this inequality symbol to be a greater than or equal to sign. So we'll have w is greater than or equal to 2 over 41. I'm just going to leave that as a fraction. Now the other ways we could write this answer is by using an interval notation. So we could say 2 over 41 comma infinity. Notice I'm including the 2 over 41, so that's why there's a square bracket here, and all numbers greater, so right up to infinity. And the graph on a number line would just look like this, where you had 2 over 41, and that dot would be filled in because it's included, and all numbers greater, so shade to the right. Or verbally we could say all numbers greater than or equal to. Greater than or equal to 2 over 41. Now sometimes we have to solve a three-part inequality. And by three parts we mean there's really two inequality symbols. Like here we have a less than and a less than or equal to. So there's three different parts. There's a 7 is the first part, and then 5 minus 2x is the middle part, and then 13 would be the third part. So three parts. And our goal here is to get x by itself in the middle. So right now we have 5 minus 2x, and we'd like to get that down to just being an x in the center here. And so the first step would be to remove this 5. So we'd subtract 5 from all three sides. So this time whatever you do to one, you have to do to all three. So that would give us 2 is less than negative 2x is less than or equal to 8. And then we'll divide all three sides by negative 2 because we're trying to get that x alone in the middle. Now remember, we're dividing by a negative number right now, which means we have to reverse the inequality symbols here. So the less than would turn into a greater than, and the less than or equal to would turn into a greater than or equal to. And so we're going to end up with a negative 1 is greater than x is greater than or equal to negative 4. Now the answer kind of ends up backwards here because we had to reverse our symbols. So we want to try to rewrite this the other way around with negative 4 coming first, and then kind of read it from right to left. So negative 4 is less than or equal to x, which is less than negative 1. So I'm going to rewrite it in the other order. When you rewrite it in the other order, notice that requires switching the symbols as well. And so that would be your inequality solution. And the different ways of writing this answer would be using a graph. You would plot the two endpoints, negative 4 and negative 1. And you want to include negative 4, so you would use a filled in dot there. And you don't want to include negative 1, so you use an open dot on that side and shade everything in between because x is in between those two. Using an interval notation, you would put a square bracket because you're including negative 4, and then a comma, and then negative 1 with a parenthesis because you're not including that one. And verbally, we would just say all numbers between negative 4 and negative 1, including negative 4, but not -1. Next, I'd like to explain how you can solve an inequality graphically. Now notice here, we're asked to find x where f of x is greater than g of x. So you want to think of f of x being the y value for that function and g of x being the y value for that function. So f of x is greater than g of x if that y value is greater than that y value, meaning that this would be higher vertically than this one. So you're looking on the graph where f is higher vertically than g. And that happens throughout this region here, where f is higher vertically than g. So we want to find the x values for which that happens. And the x values for which that happens, since it starts right here at x equals -1, and it's also true for all the numbers greater, okay? Now actually at -1, the two y values are equal to each other, so it's not true that one is greater than the other because they're equal. So we wouldn't include -1, but for all numbers greater than -1 on this x-axis, it's going to be true. So the solution set would be x is greater than -1. Okay? And that would be the way to write that answer. Also, we could say, on a number line, we'd put the -1 and open circle and shade to the right. That would be the graph on a number line. Or we could say, using the interval, -1, infinity. Or in words, all numbers greater than -1. Okay, and you really want to picture that right on the x-axis. So here's the -1, and for all these x values to the right of that, the f curve is higher than the g curve. Okay, now let's look at an application. In this case, we're given two models for the values of a Cadillac DeVille and an Acura Integra t years after 2009. And the top equation represents the DeVille, and the bottom equation represents the Integra. And these are the values of a 2008 vehicle in each case, t years since 2009. And the question asks, for what years will the value of the DeVille be less than the value of the Integra? All right, the key word is be less than. So we could reword this as find t when d of t will be less than I of t. Now I'm going to use my graphing calculator to solve this graphically. Notice I've entered the Cadillac DeVille model into Y1 in my graphing calculator, and I've entered the Integra model into Y2. So I'm going to go ahead and have my graphing calculator graph these two together, and I'll press my window key, and that'll allow me to set up my viewing window. Since x represents the number of years, I'll put in 0 as the minimum, and I'll leave 10 as the maximum. And y represents the value of these cars, so the minimum could be 0. The maximum value, I'm going to put in 30,000 because that should cover it. And I'll scale that by increments of 5,000, and then hit the graph key. Now that first line is the Cadillac, and the second line is the Integra information. We need to know where they intersect. So if we do second and then trace, and then we'll use number 5, intersect. We've done this before. We hit enter for first curve and enter for the second curve, and then move the point close to the point of intersection, then hit enter a third time, and it gives us the point of intersection. Now we have to be clear about which line represents which car, and the Cadillac DeVille D of t is the line that starts out higher but then comes down kind of sharply. And the integra graph is the other one. It's this one here. It starts out lower but then ends up higher down the line. Now we're asked to find when is d of t less than, now less than means lower vertically on the graph. When is d of t lower than I of t? And that would happen over here in this range, where here's d of t and it's lower than I of t. And when we write the answer, what we want to do is write all these x values that would be along the x-axis corresponding to that portion. The point of intersection right there is 3.7, so it's going to be true for all x greater than 3.7. So the solution set there would be t is greater than 3.7 years. Now you could also solve this problem algebraically by taking the expression for d of t, which is negative 3548t plus 26,440, and setting it less than I of t, which is negative 1333t plus 18,243. And again, I'm not going to solve this all the way out just to save on time here, but you'd want to try to get your variables over here on the left side and your numbers on the right and solve it algebraically, and you should be able to check that it comes out to the same answer that we got when we did it using the graph. And I'll leave that as an exercise for you to check out on your own. I'd like to look at one last application that involves us setting up models and then using that information to create an inequality which we can then solve. Now here it's told that U-Haul office rents 10-foot trucks for a one-day fee of $19.95 plus 69 cents per mile. So that's the key information. And one Penske office charges a one-day fee of $29.95 plus 39 cents per mile. And we'd like to use this information to set up some models for both U-Haul's charge and for Penske's charge, where D represents the number of miles driven in one day. So we want to find equations for U-Haul. I'll call that U to stand for U-Haul, and it's a function of D, the number of miles driven. Now U-Haul charges $19.95 plus an additional 69 cents, so 0.69 times however many miles are driven, which is D in this case. D stands for driving mileage. And we'll do the same thing for Penske. We'll call that one P of D. And the charge there would be $29.95 plus 39 cents times D, the number of miles. So that really answers part A. We found equations for both U and P. Now part B says find how many miles driven is the one-day charge at U-Haul less than the charge at Penske. So we want, the key thing here is that U-Haul is less than Penske. So we want U to be less than P. So we're trying to solve U of D less than P of D. So when we set that up, that just requires plugging in for the two expressions. So we have 19.95 plus 0.69 D is less than 29.95 0.95 plus 0.39d. And we need to get our variables on the left, so I'll subtract 0.39d from both sides. And let's just see what that gives us. So 19.95 plus 0.3d is less than 29.95. And we need our numbers on the right side, so I'll subtract 19.95 from both sides. And I'm running out of room here, so I'll continue up above here a little bit. So that would give me 0.3d is less than 10. And then we'll divide both sides by 0.3. Now we're dividing by a positive number, so we'll keep the inequality going the same direction. 33 1/3 miles. So that's telling us that if the driving mileage is less than 33 1/3 miles, that the U-Haul charge would be less than the Penske charge. So if you were the one renting this truck, if you were planning on driving less than 33 1/3 miles, it would be cheaper for you to rent the U-Haul. But if you were planning on driving more than 33 1/3 miles, then the Penske truck would be the better deal for you.